Yes, very good morning. Concerning today's class, the third batch, that is 11 to 15, you please unmute your mic and you please join with us till the end. 55, 59, 62, 71 and 74. You please unmute your mic and you please join with us till the end. Yes, whether my slides are visible?
Yes, sir.
Joshua,
Yes, sir.
Kabilan, Joshua,
Yes, sir.
my slides are visible
Yes, sir. Visible, sir.
and it is audible.
Yes, sir.
Yes, this is what we were seeing in the last class, that is Lagrange interpolation, and in that we were solved around 3 to 4 problems. Exercise number 1, exercise number 2 and 3, and we need to begin with inverse interpolation. Now I wanted to disseminate the content from unit 4. Once the unit 4 is over, at that time we will come back to unit 3. At that time we will see the things which left in unit 3. So in today's lecture, I would I wish to disseminate the content related to IVP and BVP, that is initial value problem and boundary value problem. And see, these types of initial value problem and boundary value problems are directly applicable to our field, that is not to find various problem associated with these one-dimensional heat flow equation and one-dimensional wave equation, that we are depending these types of the partial differential equations. For that, we need to know about what is initial value problem and what is boundary value problem and all. So the second order ordinary differential equation in the form of that is y double dash plus a1 y dash plus a2 y is equal to f of x. Yes, are you with us? Apart from Joshua, nobody. Kabilan.
Sir. Yes.
Yes, Kabilan. Kirti. Karti Jayant.
Sir.
Jayant,
Yes, sir. Yes, sir.
okay. And 14. Dhanush.
Yes, sir. Yes, sir.
Yes, Dinesh. Yes, Dhanush.
Sir.
Dhanush, you are from
Yes, sir. Andhra Pradesh, sir.
Andhra Pradesh. Okay. Okay. Shall we continue the classes, Dhanush?
Yes, sir.
Yes. Okay. See, this is what the second order ordinary differential equation. I am making this, that is d square y by dx square as y double dash. So this is what differentiated with respect to x 2 times. So y double dash plus a1 into y dash plus a2 y is equal to f of x. So this is what written here, that is d square y of x plus a1 into, we have the coefficient which the coefficient started from the y dash. Here the y dash is denoted as d, and if one time the y was differentiated with respect to x, then that is denoted as d. If it is differentiated with the 2 times, then that is what written as d square. So a1 d y of x plus a2 y of x is equal to f of x. So this is what written again as y double dash of x plus a1 into y dash of x plus a2 into y of x is equal to f of x. So we can neglect all the things we have x, these second order differential equation, these differentiation made with respect to x. So we can neglect x. In a short form, we can write it as y double dash plus a1 into y dash plus y is equal to f of x. So in some problem, they will describe or they will detail in this form. In other problem they will detail along with x. In some other problem they will detail about d. In some other problems they will detail with these the conventional method, that is d square y by dx square. So all these forms has to be known before having an idea about the basic informations. So let these the second order partial differential equation in the function of y of the two independent variable, that is x and y, which is in the form of, see, this is what ordinary differential equation. And now we are conscious about the partial differential equation. So a into a x comma y, dou square u by dou x comma y, dou square u by dou x dou y plus c into x comma y, dou square u by dou square y plus f of x comma y comma u comma dou u by dou x comma dou u by dou y is equal to 0. So this function, whether it might be linear or non-linear, that is what our concern. If the b square minus 4ac is less than 0, then a type of equations are called as elliptic equation. If it is equal to 0, then that is parabolic equation. If it is greater than 0, then that is hyperbolic equation. So these partial differential equation seems in the form of our regular polynomial equations. Instead, we have instead an coefficient like ABC. We have the a of x comma y, since it is independent variable of x y, and we have the partial differentiation. Here the a is associated with the x, and that too it was differentiated 2 times, and here it was dependent, the b is dependent of x and y, and c 2 times partial differentiated with respect to y, and we have the constant terms like c. Here we have the function of x, whether it might be x, y, or u, or dou u by dou x or dou u by dou y. And so the a is the term a. Very importantly, the term a is associated with dou square u by dou x square, and the term b is associated with the partial differentiation of dou x dou y, and c is the term which is associated with dou square y. So when we are concerning about these a, b, c, when b square minus 4ac is less than 0, then that type of equation is called as an elliptic equation. If it is equal to 0, then that is parabolic. If it is greater than 0, then that is hyperbolic equation. See the elliptic, parabolic, and hyperbolic equation. So what was the information we need to carry from the past slide is, here dou square u by dou x square plus dou square u by dou y square is equal to 0. Then that is called elliptic equation. We can apply, we can find one by one. That is we are going to find whether this falls under elliptic or parabolic or hyperbolic. I'll tell you with the example. We will describe whether these falls with the elliptic or parabolic or hyperbolic. So this is what the basic form of elliptic equation, that is dou square u by dou x square plus dou square u by dou y square is equal to 0. So see, you try to apply this with this equation. That is a, we have the a, instead a we have only 1, and instead c we have 1, and b doesn't have any other term like b. So b doesn't have b, so it begins with minus 4 into 1 into 1, so it is less than 0. So the elliptic equations usually in the form of uxx plus uyy is equal to 0. U, which is differentiated 2 times, that is what the subscript xx, and similarly uyy is equal to 0. So whether it is clear, this equation v doesn't have any term v. That is the partial differentiation with respect to xy, and so we don't have b, so b is 0. minus 4ac, minus 4 let it be, and instead a we are going to apply 1, and c is also 1. So minus 4, that is always less than 0. So these types of these problems which having this equations has to be false under elliptic equation. Among elliptic, we are going to deal with two different equations. One is Laplace equation, that too with the 2 dimension, and the Poisson equations. The Laplace, this is what the Laplace equation. See, this is what the Laplace equation. Poisson equations usually in the form of dou square u by dou x square plus dou square u by dou y square is equal to f of xy. Even here also we doesn't have any term like b, so there won't be any change with the minus 4ac. Here the constant doesn't influence over these three different equations, because it doesn't have any influence here. We have that a term, the influence with these a, b, c alone will decide whether this falls under elliptic, parabolic or hyperbolic. So these two usually called as an elliptic equation. Under elliptic or beneath belly elliptic, we are going to deal with Laplace equation and Poisson equation. See, this is what the other parabolic equation, uxx is equal to a into ut. See here, dou square u by dou x square minus a into dou u by dou t. Here we doesn't have any b term. We have only the x term alone. X that is that which is a, while applying here minus 4 into a 1, and c we doesn't have any c term also, so c is also 0. So there won't be any influence of a here. Minus 4 into 1 into 0, that becomes 0. So this type of equations is categorized as parabolic equation. That is uxx is equal to a into ut is a parabolic equation, under which we are going to deal with the one-dimensional heat flow equation, whether it might be and dependent of schemate or Bender schemate or Crank-Nicolson. This is what the problems we are going to deal. That is A1 is Laplace, A2 is Poisson equation, B1 is schemate, and B2 is Bender schemate, and B3 is Crank-Nicolson, and the C under C, that is we are going to deal with one-dimensional wave equation, explicit wave equation. Here uxx is equal to utt, instead y. Here we were converted with t. By making this with one side, how we can return this as uxx minus a into utt. What happens? See here, instead yy, we were converted with the y with t. So the formula is same here. Can somebody you tell me apply with these b square minus 4 is, and whether it is greater than 0? You tell me, someone. Kabilan.
Sir, there is no constant term, sir. So we can
little louder, Kabilan. Little louder, Kabilan.
Constant term is 0, sir.
Okay, whether we have the term b. See here whether we have the term, that is we both associated with the x and the t. We doesn't have any.
Yes.
Okay, b is 0. Okay.
Yes.
What is a?
A is 1 in this case, sir.
1, of course, 1. And then what is c?
Minus a.
Of course, right. You apply here b square minus a 4ac.
We'll get 4 times of a, sir.
4 times a. Yes. Yes, a became 1 and c became a, minus a. So which always returns and positive for a, right?
Yes, sir.
So it is always very good. It is always greater than 0. So these type of equations are categorized as hyperbolic equation. If it is less than 0, elliptic. If it is equal to 0, that is parabolic. If it is greater than 0, that is hyperbolic equation. Under elliptic, we are going to deal with Laplace equation in Poisson. Under parabolic, we are going to deal with one-dimensional heat flow equation, and under hyperbolic, we are going to deal with one-dimensional wave equation. And this is what your exercise number 1A. You start writing these contents. 1A, 1A, x square f of double f x6 plus 1 minus y square f y. Instead here what we were written, various forms, that is the conventional method d square y double dash of x, y double dash alone. And here in this problem they were detailed with that is fxx. So the thing is, when it was the term which is associated with y double dash, it should be a. When it is associated with dou x dou y, then that should be considered as b. When it was with y the y, then that should be taken as c. So here what happened, x square f x plus 1 plus y square into f y is equal to 0. The y varies from -1 to 1 and x varies from minus infinite to infinite. So this is what the basic equation. This is what the basic information which we are getting from the past. So here instead a we have x square, instead b we doesn't have any b term, c the term which is associated to the FOY, that is 1 minus y square. And applying in here b square minus 4ac, b square is 0, so therefore b doesn't have any term b minus 4 into, instead a we applied x square and c 1 minus y square. So 4 I am applying this minus into the equation, that is y square minus 1. The x square is, here we have the term x square. When the values are between minus infinite to infinite, it doesn't have any influence. Just a minute. Just a minute.
It's not a pirate announcer.
Yes. So x won't change the sign conversion. So x is always positive when we are varying the y value. Whether my slides is visible, Kabilan? Kabilan?
Yes, yes, sir. Yes, sir.
Okay. When we are changing the y from -1 to 1, what happens? y is all y the term let it be 0. What happens? This returns minus 1. Let it be 1. What happens when we are applying a positive value? 1 minus 1, that becomes 0. When it varies, when it was minus 1, minus 1 square, that also becomes 1. So when we are applying the values in between, it is not equivalent to minus 1 or 1. So it should be between minus 1 to 1. So when we are applying a minimum value than 1, what happens? It always returns the negative value. So my b square minus 4ac is always negative when x is not equal to 0. So this is what the equation, the example of elliptic equation. Whether it is clear? Is clear? Kabilan?
Yes, sir. Yes, sir.
Yes. Okay. I will start the second problem. Before that, what happened in yesterday's match? Kabilan?
Sir, CSK won, sir.
CSK won. I think Mumbai is at the top with a higher point, right?
No, sir.
No,
CSK.
sir.
CSK, sir.
CSK is at the top.
CS,
And then
CSK is the favorite.
RCB.
What?
Mumbai in
No,
fourth
no.
place.
It was the I think recent status. What was the yesterday's status before having they defeat with
CSK was
Delhi
in
was
top.
first.
Sir,
Delhi
before it
Capitals
was in
was
second position, sir. Yes.
Yeah, like
Delhi,
Delhi.
CSK.
Delhi,
Delhi was
Mumbai,
in
and
top.
CSK. One,
So
one,
Delhi is
anyone.
Mumbai was in
CSK.
fourth position, sir.
No, sir.
Let Kabilan, yes, others, you please wait. Others are always active. I know. Will request some others. Kabil,
Sir,
Kabil.
before the match, Delhi was on top, followed by CSK, then RCB, and then Mumbai, sir.
Okay. What was the today's scenario?
After that, CSK has come to the top, followed by Delhi, then it's Bangalore, and then Mumbai, sir.
Oh, Mumbai won't in the top.
No, sir. No, sir.
Okay. What happened yesterday's match? You please decide. Kabil, what happened in yesterday's match?
What happened? You're asking, sir.
Ah,
Well, CSK started batting, sir, and within power play they had lost 4 wickets, and then
okay.
Ruturaj Gaikwad and Jadeja had like stabilized the batting, sir, and they had posted a score like 155 or something. Then
156.
Mumbai had like a
Hmm.
batting collapse. Rohit was not there, and they lost, sir.
Okay, good. Anyone? Some other fellow. You please from the active person. I think for me started our Pranav.
Yes, sir. Ruturaj Gaikwad, he played very beautifully, especially like I mean, like last year, with a statement coming like saying like in wherein like the captain Dhoni, he said that we didn't see much of spark in the youngsters and all. And even last year versus Mumbai in UAE, he didn't play that much good. It was only during the last part of the season he started playing well. So like for him, it was a major confidence booster because he played versus like a top class bowling attack of Mumbai Indians, and he was able to um, with ease like he was sweeping the Yorker balls, and also versus India's best bowler Bumrah, he hit a very beautiful shot and all of that. So that was like I mean for a youngster to take up that responsibility of carrying the team throughout the innings, it was something which is very phenomenal. And yeah, so in that way, like yes, sir, like that was like the highlight of the match. And of course, like CSK bowled well, and Mumbai Indians succumbed to pressure, and that's how CSK won the match.
Yes, of course. I think 80 plus he got right.
Sir,
88, sir.
88 not out, sir. Till the end
88.
he was there. From the start till the end he was there. Like he started out slowly because wickets were piling up. It was a mature knock, sir. I mean, then slowly progressed, and once he attained stability, he started hitting the big shots and all of that. So yeah.
Okay. Yes, yesterday it was started yesterday, right?
Yes, sir.
Okay, okay. We'll start and we'll discuss again once we'll disseminate some content related to these basic informations. And again, we request some other fellow to make a detailed note about other things related to this T20 and the current affairs. And this is what exercise 1B. Still, we are in the first problem. In the first problem itself, I have categorized as A, B, C, D. And see, x f x x plus y f y y is equal to 0. X always greater than 0 and y also greater than 0. So here the a is equal to x, c is equal to y, and b doesn't have any term b. B square minus 4 is equal to 0 minus 4 into x into y. X is always a positive value. Y is always it is greater than 0. So there won't be any influence of this with this negative, and this negative won't turn into positive. So it is always less than 0. That is on the whole, that is b square minus 4ac is always less than 0. So it should be categorized as elliptic equation. Hope you returned these contents. And 1c fxx minus 2 fxy is equal to 0. Here also x and y always greater than 0. Here the term a is equal to 1, b is equal to minus 2, c is equal to 0. Here I have applied b instead b, that is 4 minus 4 into 1 into 0. So the 4 minus 0, 4, which is greater than 0. So this is what the example for hyperbolic equation. And uxx minus 2uxy, whether it might be u or f, what we need to take the coefficient minus 2uxy plus uyy is equal to 0, a is equal to 1, and b is minus 2, and c is 1. So 4 minus 4 into 1, 1. So that is equal to 0. This type of equations are categorized as parabolic equation, where b square minus 4 is equal to 0. F1b fxx plus 2 f of xy plus 4 f of yy is equal to 0. X and y always greater than 0. So a is equal to 1, b is equal to 2, and c is equal to 4. So b square 4 minus 4 into 1 into 4, 4 minus 16. So minus 12. This is what less than 0. So the equation is elliptic. So I think these things are well aware. You can find when an equation given to you, you can find. I hope you can find whether that falls under elliptic, parabolic, or hyperbolic. Whether it is clear. Abhilan and his team, the five.
Yes, sir. Yes, sir. It's clear, sir.
Okay, Jayant, Danush. Shall I move ahead? Shall I move ahead?
Yes, sir. Yes, sir. Yes, sir.
Okay. So elliptic equation, that is standard 5-point formula. This is what the standard 5-point formula. See, u I. This is what I positive and I negative. Sorry, j positive, I positive, and j positive. Let this point, assume this is an Cartesian the coordinates. You think whether this is available in the Cartesian coordinate, and this is what your origin. Your origin should be ij. What happens when you are traveling from this point to this point? What happens? One comma j. There won't be any change in the j, since we are in the I. In the I, so you I j plus 1 similarly here ui comma j minus 1. What we are going to do, we are going to find this ui comma j with the aid of these four informations. So with this the pictorial representation, you can remember this standard 5-point formula. 1 by 4 of, we have 4 terms, so 1 by 4 of, I am starting I'm starting from here, that is from the I-axis, but it might be clockwise or counterclockwise. Follow some orders, so there won't be any mistakes will happen during the solution. So I minus 1 comma j, ui plus 1 comma j plus ui comma j plus 1 plus ui comma j minus 1. What we did, we were accumulated all these four, and this has to be divided by 4, which returns ui comma j. This is what the standard 5-point formula. And similarly, we are going to deal with the diagonal 5-point formula. This is what the diagonal 5-point formula. ui comma j, this is what the axis I and axis j. Here ui plus 1 comma u j plus 1. Here we are in the same I plus 1 axis. Here ui minus 1 axis. This was j plus j plus 1 and j minus 1. So u of I plus 1 comma j I plus 1, u of I plus 1 comma j minus 1. Here both are minus, I minus 1 and j minus 1. Here I minus 1, j plus 1. So this two, with the aid of these two equations, we are going to find our unknown in the subsequent problem. Elliptic equations, whether the elliptic equation can be written in two different forms, whether it might be uxx plus uyy is equal to 0, or uxx plus uyy is equal to f of xy. In both the way, both the equations are seams or falls under elliptic equation. If the given equations in this form, then we need to take that is as an elliptic equation. So this is what the Laplace equation, that is dou square u by dou x square plus dou square u by dou y square is equal to 0. These boundaries usually given in the problem. Here a1, a2, a3, a4. What is the time? That is 10:21. We'll wind up here. We'll begin with a short break. We will continue our classes. Here a1, a2, a3, a4, a5. It continues till a16. Our focus or our interest is to find the intermittent points, that is u1, u2, u3. Let the this boundaries or laminas of one particular temperature effect problem, the atmospheric temperature or the surround here the boundaries temperature would be a1 to a16. Our interest is to find the temperature at the intermittent points. So with this we can find various informations, that is based on the Laplace equation. We can find the various values of u1, u2, u3, u4 till u9 we can find. And see, this is what the standard 5-point formula. We can find the u5 first, and then we can find the various u1, u3, u7, u9, and then u2, u4, u6, and u8. For finding u5, we need depend with standard 5-point formula. For finding the u1, u3, u7, u9, we need depend with diagonal 5-point formula. And for finding rest, that is u2, u4, u6, and u8, we need depend standard 5-point formula. I'll tell you why these we need depend these, whether it might be a standard 5-point formula or whether it might be why we need depend diagonal 5-point formula. With a short break, we'll continue our classes. You leave the meeting and you again join after break.
Okay, sir. Thank you, sir.